Hi guys. Lesson 7 is chemical and physical properties. Um, Before you continue with this video, make sure you have access to or have available 2 glasses of water, um, some sugar, at least a tablespoon of sugar, and a tablespoon of oil. I want you to have all of these things printed out, a calculating volume and density sheet. There's also physical or chemical properties. There's 2 pages for that one. And physical properties, oh, sorry, the vocabulary. Yeah, that's right. Get that printed out too and read them over, and then also put them on your science wall. And we are probably going to wait and talk about these specifically more in class, but on Thursday. But it would be good for you to know for some of these activities you'll be doing. There's also the elements part 2, which I don't have loaded up yet, but I will hopefully soon. And then I have this other book, it's Chemical Reactions, part 1 and part 2. But I also, if you don't want to listen to me jabber on and read it, then just open it up, because I put it on a PDF on the right next to the videos on the website. So then you can just read it from your computer. You don't need to print it out or anything. You don't need to watch my video where I'm trying to speed through it. So anyway. So some of my students from last semester know that in science we look at physical properties. We look at what it looks like. What does it sound like? What does it feel like? What does it smell like? How heavy is this? What is the color? The texture? So physical properties are those that you can see. They are characteristics of an object that can be observed without changing its chemical identity. If we were to cut or break an object, we would not be changing what it is. Its chemical identity would still be the same, since the molecules that make up these objects are still the same. So, for instance, if we were to break a rock because we wanted to learn about its strength, we wouldn't be changing its identity as a rock. However, if we were to change something in such a way that changes its chemical makeup, we would be able to observe its chemical properties. Chemical properties are observations made about a substance during chemical changes. During chemical changes, the atoms rearrange themselves to form a completely different substance. Oh, our bodies produce chemical changes every day. When we eat, the digestive enzymes in our bodies break down our food to process the nutrients extracted from the food. Our digested food is not the same as it was on our dinner plate as when it comes out, right? The enzyme in this image is called pepsin. So through digestion, it is a chemical change because it's totally changing. Unless it's corn. Okay, so another example occurs when wood is burning. When wood burns, it does not undergo a phase change and turn into liquid wood. Instead, it reacts with oxygen in the air and undergoes a chemical change. This change results in ash, carbon dioxide gas, and water vapor. You may also notice that energy is converted because light and heat are produced, because the wood had to be changed chemically by burning to make these observations. We know that combustion or burning is a chemical property of wood. Some chemical changes can be reversed, but only by going through another chemical change. One example is separating water into hydrogen gas and oxygen gas. When doing this, water changes into something completely different and no longer has the same physical properties. For hydrogen and oxygen to form water again, they must go through another chemical change. Even though the atoms of hydrogen and oxygen are still the same, the way they are bonded changes, resulting in completely different substances. Haha, look at that. That's the ugliest egg I swear I've ever seen. Some reactions reverse more easily than others, and some reactions are irreversible. For example, if you cook an egg, the heat permanently changes the proteins in the egg, causing a chemical change. The way the atoms are arranged in a raw egg is different than the way the atoms are arranged in a cooked egg. No new atoms are being formed. They are just breaking and reforming bonds differently. Do you remember the example of the towers and the building blocks from a previous lesson? Cooking an egg is like breaking the glue holding the blocks together on a tower, moving the blocks around to form a different looking tower, then reapplying the glue. Your tower looks different, but you are still using the same blocks. Think about what we learned about phase changes. When water freezes, boils, or melts, the bonds that hold water molecules to each other may break or form, but the attraction forces that hold water molecules together to make water do not break. Even though we can see that ice, liquid water, and water vapor look different, the water molecules haven't changed into new substances. Therefore, phase changes are observed as physical properties. The best way to determine if you are seeing a physical or a chemical property is to ask yourself, is it new stuff? Or is it the same old stuff looking different? If you can only notice this property by changing the substance's chemical identity, then it is a chemical property. If you can observe that property of a substance without subjecting it to a chemical change, then it is a physical property. Let's discuss some examples of physical and chemical properties in greater detail. Solubility. Solubility refers to how well a substance dissolves. Now I want you to get out one of those glasses of water, okay? And that is our solvent. And then I want you to get out 1 tablespoon of sugar, and that is what they call a solute. And when we mix them together, the sugar water forms a solution. A solution is an evenly combined mixture of more than one substance. You can go ahead and pour your solute, or your sugar, into the solvent, which is the water, and mix it up and see what happens. The solute is the substance being dissolved in a solution, and the solvent is what does the dissolving. Now, what do you notice? Now what I want you to do is write down what you notice about your solution when you have water and sugar together. And then you're going to get out that other glass of water with your tablespoon of oil, And you are going to put the oil into the water. What do you notice? Solubility is a physical property. The substances are simply mixing, not reacting to each other, like metal and acid would. Based on what we observed with these two examples, is sugar soluble in water? Yes. Is oil soluble in water? No. Corrosion. Corrosion happens frequently with certain types of metals. Corrosiveness is a chemical property because a metal, like iron, will react with oxygen in the presence of water to form rust, which is iron oxide. Iron oxide has completely different physical and chemical properties than iron and oxygen. Another example is the green coating that forms when copper corrodes. Did you know the Statue of Liberty used to be brown, like a copper penny? Over time, the copper corroded, forming the green outer layer. Volume. Volume, or how much space something takes up, is also a physical property. This example measures volume by showing how many cubes fit into the rectangular prism. We will use the measurement of centimeters. When we multiply the length times the width and the height of a rectangular prism, we find its volume. What is the volume of this rectangular prism? Well, we got 3 times 2 times 2. And can you tell me the units when you're done? 12 centimeters cubed, or 12 cubic centimeters. This means that we can fit 12 1 centimeter cubes into this box. So now what I want you to do, that was your little example and preview.